The data on lives of batteries of a particular type and industrial application have been obtained in years. We have got 36 such values. And our objective is to develop the box and whisker plot in Microsoft Excel. For that very purpose, I copied this data in an Excel sheet, and this is here. And earlier, I also developed some calculations, but let's repeat those things. So this is the data, and I have arranged the data just in one vector. So all values are in just one vector, and that is in A. I think it is good to improve the view, the font size. So I hope this is visible. The values are visible. Now, in calculations of quartiles, we have to sort the values. So I say sorted values, and over here I will write the function sort the whole array, which is A to A37. And I hope I have covered the whole domain. Right. So these are all the 36 values. And in sorted form, they are from 1.8 with the minimum value 1.8 and to the maximum value of around 6.3 years. Right. So this is the sorted one. You can do that by just selecting these values and making a click on the sort and filter options. Like from here, sort and filter. But it is not good. I must select the respective values. And there are several options in doing the sorting. So you have from smallest to largest, from largest to smallest, and the custom sorts, which are applicable on several columns. And if you like to arrange them on a different criteria, we have one column. There is no need to go for that kind of sorting. So you can just do the sorting of smallest to largest. Okay, so that will be applied, right? Okay. With the sorted data, let's find out the data values. So first value, second value, this is just the numbering of the data in ascending order. And if you plot this one, it is going to be similar to a curve like give curve. Then the calculation of Q value. So we have to pick up the ith value and then divide by the total number. So we have 36 observations. You can multiply it with the 100 to get it converted to percentages. 2.78, and repeat all that for the cells below. Okay. So very nice. Now let me develop a fresh box and whisker plot. So I look for the the charts available. So this one that we used earlier to develop the histogram, now we will use box and Ishkar plot. So this something has been developed. Okay. Just space is reserved for developing a chart, and then select the data. The data is available in the column A and also in column C. I will choose the data values from column A, right? Because it does not require the sorting of the data. So you can just apply this one for the data written in provided in the in a vector, in an array, right? This was required for developing the box and Whisker plot. You cannot deal in with the data given in two-dimensional array. So just with making a click, since we have only one data set, therefore series name is not that required. If you have more than one data set, then you must have the marking of that as well. So the graph will be developed. Well, I have been struggling with the buttons of my laptop. Okay. Nevertheless, the graph have been generated, right? So let's see whether it has been developed according to our calculations or not. So let's see. Here is a value somewhere. What? Okay. Here we have found one outlier. Let's see how it has been selected. And we have the whiskers extending outwards from the box, and we have the box there. So this one represents the level of median value. So we can pick up the 50%. Where is that? Let's look for it. So at 50%, the value is 4.5. Okay. At 25, the value is 3.9. Let's mark it. And then at 75, we have value 5.1. So let's see whether they are consistent with our observations, our calculations, and from the automatically generated graph. So somewhere 3.9, then it is 4.5, and this is 5.1. Right? So consistent with the quartiles and medians, right? You can also see the maximum value 6.3, and the value generated here for this much percent, that is 2.3. So automatically Microsoft Excel has considered 1.8 as an outlier. So we can compute the mean value. So let's consider the mean value, mean with 100% of the data. So to compute the arithmetic mean in Microsoft Excel, you can use the function average. I compute the average of A to A37, right? So it is 4.44. Let's compute the average value by rejecting 5%. So with 5%, so we have 2.3 value, right? We can neglect values which are below 5%. We have to include 2.3, because the value is here 5.56. It will be rounded to 6%. Let's see from the bottom. So if you neglect 5%, so you have to eliminate the two values from the top side, right? So equivalent percent of the data have been removed. So the 5% trimmed mean, neglecting 5% values from both sides, concept which is known as trimmed mean. So mean at 5% trimming. So for this case, I have to compute the mean value. Average from A, I have to neglect the first value. So from A3, 5% have been neglected from the lower edge and 5% from the other side. So I have to compute till A35. We found that the data was not that symmetric. So therefore, 5% on the lower side was equivalent to one value and 5% on the upper side was equivalent to two values. So that is the due to the non-symmetry of the data towards the edges. We have got the value of 4.53. Similarly, you can see the mean value by rejecting 10% of the data on both sides and see the mean value. And if the mean value is not variable within the bounds of your error, and the bound of error is defined by the standard deviation. Let's see that one so that everything becomes clear. So let's compute the standard deviation. Microsoft Excel, standard deviation STDEV dot P for population and S for sample. So clearly from this experiment, we have taken 36 batteries and we have tested them for their life. Of course, the companies develop several thousands of the batteries. So it means it is a sample, right? So for sample, and I compute from A2 to A37 for all the values. So 1.02. 1.02 is the error bound, standard deviation. So with one standard deviation value, the error bound 4.43 and 4.5, they make no difference, right? They make no difference. Therefore, uh, the values can be taken as consistent, and you can the 100% mean computed from all the data and the mean computed by 5% trimming make no difference in your calculation because they are well within the range of the standard deviation.